Here are solutions to test number 1 for ECE 461-661 control systems. The first problem looks at ladder logic. Given the following ladder diagram, come up with the logic relating for logic for x and y. With ladder diagrams, the notation is series is and, parallel is or. So this would be A or D. That's in series with, meaning ANDed, with B bar. That's in parallel with YB. That's in series with C. And parallel with C bar. So all that together gives you X. And then Y is series and A and X bar. Doesn't have to make sense. That's just what the ladder diagram says. Problem 2. Problem 2 is find the transfer function that has that step response. I know right away it's a second order system because it's oscillating. So I'll call that A over S plus B plus JC and its conjugate. Then I can get B from the settling time. I call the settling time right around here. Let's call it 240 milliseconds. Then B is 4 over 240 milliseconds. C is the frequency of oscillation. So I've got 1, 2, 3, 4, 5, 6, 7. 7 cycles in 195 milliseconds. That's frequency in hertz. Anything English is wrong, general rule of thumb. Multiplied by 2 pi, I get radians per second. And then A is a fudge factor. Pick A to make the DC gain 1. And that gives you the transfer function. So put it all together, that's roughly what I got. Your answer is going to vary a little bit. Problem 3. Find the transfer function from x to y for this block diagram. And kind of two ways to do it. One is the shortcut, going from x to y, that's the numerator. So here's one path, B, C, D. Here's another path, A, D. That's the numerator. Denominator is 1 plus the loop gains. So here's one loop right here. That loop gain is C, D, E. And here's another loop, B, C, D, F. Now if I'm taking the FE exam and I'm in a time crunch, that's what I would use. A second way that always works, and the shortcut usually works, occasionally doesn't. What always works is define a variable at the output of each summing junction, then write the equations. M is x minus f times y. N is minus e times y plus b times m. Y is d times c times n plus d times a times x. So I get my three equations. Now do some algebra. Solve for n, substitute for m, and substitute. Do some simplification, and eventually get the same answer. It's problem 3. Problem 4. Write the dynamics for this RLC circuit. Now the trick is for inductors, I have V is LD IDT. S means derivative. And for capacitors, I equals C dV dt. Again, S means derivative. So for the capacitor, the current I1 is C dV dt. That's the current, which is Vn minus V1 over 2, this term, minus I3, minus this current, which is V1 minus V2 over 3. That's C dV dt. Second capacitor, I2 is C dV dt. That current is the current in, I3, minus I4, plus V1 minus V2 over 3, minus V2 over 11. For the inductor, V is LD IDT. The voltage is V1. Voltage on the right is minus 4 times I3 minus V2. And the last one V is L didt. That voltage is just V2. Problem 5. If I have these dynamics, express them in state space form. So the first trick is rewrite the dynamics, putting the derivative on the left, everybody else on the right. Then in matrix form, SV1 is, well, what I like doing is just reminding myself, first column is times V1, V2, I3, and Vn. So the first equation, SV1 is 5 times Vn, minus 5 times Vn, minus 3.3 Vn gives you minus 8.33 V1, plus 3.33 V2. SV2 is 1.25 V1, minus 1.25 V2, minus 10 I3, and so on. The output is 4V2 minus 5I3. In matrix form, that's 4V2 minus 5I3. And that's test number 1 for 461, 661.